Hello. Yesterday, I wanted to write a dictionary program that I could use on the terminal. And while I've used Google for a while now for my dictionary needs, I've been trying to de Google my life lately. But building your own dictionary is kind of a pain. It would involve crawling publicly available dictionaries to build your own data sets and a bunch of other work. Luckily, there's this API, dictionaryapi.dev. And that's the thing about Unix like programs. You're not trying to reinvent the wheel. A lot of the times, you're building on existing programs to make something that fits your own unique use cases. So, what I'm going to do today is write a program that consumes this dictionary API all in Ruby and shell scripts. Let's get started. Let's make a directory called dictionary. And I think I'm just going to start with a Ruby script called dictionary. So I need to be able to capture search terms from the terminal. So let's do that. Just do argv.join spaces. And let's see what that looks like. Ruby dictionary test. All right, so that's that. And then let's exit out of this. First, I want a search class, but it'll be inside this namespace. And we'll build an instance of that. And then I want to have a class that prints the output of this search. We'll do printer equals dictionary print definitions, and we'll build an instance of that. First, we'll search for the definitions. And then we'll use the printer to print those. Now, what exactly am I going to be printing? The format I'm thinking is a tab separated list. We're going to have the part of speech here on one, and then tab, and then the definition, and then so on and so forth. Now, I could have my Ruby program print out the details I want in the format I want. Like if we go back to the program that I already wrote, and we just do dtest, you can see that it's printed out in this nice, pretty format with some indentation and so forth. I could have the Ruby program print that out, but I found that the terminal has many different tools that are well suited to the task of printing, sorting, and doing other terminal things. Like I said before, that's the thing about the Unix philosophy. Use a lot of small programs and string them together to build what you want rather than write a single monolithic program. So this is the end goal that we're going for. And right now we're in the Ruby part. So let's go ahead and delete that. And then I'm going to create a lib directory. And I guess a dictionary directory. And then commands. And then also print. And then we have our dictionary.rb file here. And we'll need to load that up here. So we'll do that by setting the libdir equals file dot expand path lib joined with the current directory. And let's just test this out a little bit. Let's see. Okay, yeah, that's what I want. And then we add that to the load path. Exit out of this. And then uncomment this. And then we have our loader file. And we're going to need require net HTTP. I believe that the API uses JSON, so we're going to need that. and then require dictionary print definitions and require dictionary commands search. All right, let's start with the search. Let's set the module dictionary module commands class search. All right, def self dot build instance equals new. Return the instance. And then here's the search function. And first we need to fetch from the dictionary API. And that is dictionary API.dev. And we just need this thing right here. So URI equals URI. And then I guess we could do a CGI.escape in case there are multiple words in the search term. Let me actually add that to the loader file. Yeah. Oh, and I just realized this is in the wrong place. Whoops. Okay. So this needs to go up one level. Okay. And then we can say HTTPS equals net HTTP dot new URI dot host comma URI dot port. And then we want SSL to be true. And then we're getting a response from https.get URI.request URI. And then we return the response. So let's actually see what happens when we do this. So let's do a binding.irb just to pause the execution here. And this is going to break. So let's comment that out. And then let's go back here, dictionary. Okay, Ruby dictionary.rb test. Oh, I forgot to require dictionary. Oops, cannot load such file. Okay, this is still not in play yet, so let's comment that out. Okay, response.read body. Oh, okay, let's see if we can parse that out. Okay, this is a lot more readable. So there's an array of words, and inside those words, each word has an array of meanings with the part of speech, and then an array of definitions. Okay, let's exit out of here. Here, let's delete this line. I think what I want to do is I want to separate this out into its own method. And then we'll get the response from the fetch method. And then there could be a case where there's no word here. Like the word just doesn't exist. So if that's the case, we do what I normally do is we get the response code. And I believe it's in string format, so let's convert that to an integer. And then just return symbols if return not found, if response code equals 404, and return error if not response code equals 200. And then we can get our payload, parse it out. Let's pause here and then test this out. All right, we're back where we started. Excellent. So I want to return back, if we go back to our example, I want to return back an array of definitions with their parts of speech. So we have an array of definitions. And then on the payload, remember this is an array of words that each do word. And then on each word, we dig through the meanings. And we get the part of speech from the meaning. Let me check that. Yeah, part of speech. Meaning.dig, definitions. Each, this is an array of definitions. Do definition. And now we can do definitions, and then we send them something. And what I like to do is, let's go down here, is define a definition item as a struct dot new part of speech and definition. And then we just say definition item dot new with the part of speech and the definition, I think dig definition. Let's actually make this a little bit more readable. All right. And I guess we'll go here and see if that works by testing it out. Nope, I think I did something wrong there. That's not what I want. Right, I need to return the definitions. So let's try that again. This does not look correct. All right, let me see what I did wrong here. Okay. Let's see. Let's go get the payload. Oh, whoops. I'm going to need to pause here. Okay. So if you start from the top, you have an array of words, which is what I have. And then we dig in further to the meanings. So let's see. Yeah, word.dig meanings.each. And then in each meaning, there's an array of definitions. Okay. And then, oh, I see. This is a little bit confusing. So this would be, there are definitions and each has a definition inside it. So, I mean, I guess that works. All right, let's try this out. Okay, part of speech is verb, definition. Yeah, this looks correct. Okay, so now I want to print this out in a tab separated value format by passing it into this class here. So let's uncomment these. Let's get out of this, go here, and then create a new file. Module dictionary, module print, class definitions. And we do much the same we did before. Def self.build instance equals new, return instance, and then def call definitions. So we know that this is an array. And so we need to get the part of speech. And then the definition text. Oh, I could rename that to that. That makes more sense. Okay. Let's do that. Just so it's more legible. And then we'll set this to... Okay. And then once we have that, we need to have an array of values. And then we add the part of speech. And then the values, we add definition text. But I don't want this to have any tabs. I mean, it's unlikely that any definition text will have any tabs, but having any tabs will break my program. So I just strip them out and replace them. And then I can do puts values.join and then separate them by tabs. And okay, I think that's good. Let's try this out. Oh, I still have a binding in there. So let me get rid of that. But it does print out a tab separated value list. So we're done with the Ruby portion. Let's go back to home. Now I want to build a shell script. So let's do vim d. Let's chmod it. Okay. And then, okay, let's set the directory of the Ruby project. Home, workspace, dictionary. And then we get our list of definitions. With whatever is passed in. Let's try that out. Echo definitions. The test. Okay. Yep. This is a tab separated value list. Okay. I think I forgot something. Right. Okay. So here, when I am returning these symbols, I don't handle them up here. So I just leave this for this printer to maybe bungle with in the future. So if the definitions equals not found, I will exit with code 10. And if definitions equals error, I'll exit with code 1. Oops. All right, let's actually test that out. Let's just use something that probably isn't a dictionary word. And then if we echo the result code, we see we get back 10, which is what we expected. So we can do the same here, where we say result equals $? And if the result equals 10, we can print out no definition found. Actually, I will create a function to print out any errors that I get. So let's say fail, printf, %s, new line, and then whatever the first argument is, and then print that out into the standard error, and then exit the program. So here we say fail. And if the result equals 1, then we say error with service. So let's try that out. D, no definition found, exactly as we expected. And if we don't have any arguments that we pass in, like we just send in D, we don't want that. Let's try doing let's go here. Let's say if the arguments passed in are empty, we print a usage function. So let's say usage equals fail. Okay. So the first thing I want to do is number each of the definitions so that I know how many I have. So what you can do is you can use NL, which is a line numbering filter. And this is the beauty of Unix programs is you can pipe the output of each program into the input of another program and then get something better than the sum of your parts, basically. So let's say echo definitions and then pipe that into the numbering filter. So if I do test, you can see now I have filters here. And the thing about NL is that I believe the separating value is a tab. So this is separated by a tab here, just as this is. So I can use that to separate these values. And something you might think just by looking at this is you think you are done. But as you can see here, this line kind of bleeds over into the next line. It's not really formatted pretty. It doesn't really look great. And so I think what I'll do is I'll pipe it into my own function. Because while they have a program to fold long lines into specific widths, you need to do something more specific if you want this to like be indented over here a specific length. So first I need the number of columns. And you can get that with tput, I believe, by just printing out tput polls. Yeah. So I can do columns equals tput polls. And then I know how much I need to indent by doing little algebra. So if we go to man NL, we can see oh, here we go. Width. This specifies the number of characters to be occupied by the line number. The default width is 6. So we know that up to here is 6. Then we add 2. And then we add however much this is, which we don't know yet. But let's go ahead and do that. 6 plus 2 plus, I don't know, and then another 2, because I want to separate the part of speech from the definition with 2 spaces. And now we need to figure out the length of the longest part of speech. So you have noun here and verb here. Let's say you do something like hello. Oops. Okay. Ruby dictionary hello. You can see interjection, the part of speech interjection is much longer than noun or verb. So we're going to have to deal with that. So let's say we need to get the max part of speech. And you can actually do this with a program called awk. And awk has many different uses. Basically, it's a pattern scanning processing language. You can write programs with it. So here's what I do. I say, let's echo definitions into awk. And let me see again, man, awk. Yeah, okay. Dash capital F is the input field separator. So we need to do F. And then we can write our program. So we have a begin phase where we set the max equal to 0. And this phase is what happens when each of the items or lines in this definitions are iterated over. So if the length of the first argument, which is the part of speech, is greater than max, then max equals the length of the part of speech. And then print the max. Let's try that out. Okay, so the length of the part of speech is 4. Let's say hello. And that is 12. So that seems to work. So now we can add that here. And now we need to define our indent function. And here, what we do is just a while loop, reading each line from standard input. And actually, we need to set the IFS variable, because what will happen is that any trailing or leading white space characters will be stripped from the read function. So we need to do IFS equals to nothing. And then number equals echo line. And then what we can do is use the cut utility. And specifically, I believe the -f option will allow us to specify the number of the field to specifically cut out. So if we say cut -f1, that gives us the first column. Likewise, part of speech. 2 is the second column. And then we can get the definition. And then if we just test this out, we can say print f s. And then we say number. Oh, wait, no, we don't need those commas. Whoops, what am I doing? Part speech, and then the definition. And let's just test this out. Oh, right, I need a new line character. Okay. Oh, right, I need to delete this echo statement. And I kind of want to separate these. I think I said this before, but I want to separate this out by 2 spaces. Okay, that looks better. But again, we need to deal with long-running lines. So what I need to do is add some more pipes. And we can use the fold utility for this. We could say if an output line would be broken after a non-blank character but contains at least one blank character, break the line earlier. And then we can specify the width that we want the line to be. So if we fold this specific part, we can say -s and -width with the columns minus the indent. Let's see what that looks like. Okay, and then we need to add white space here. Actually, here's an interesting little trick if you didn't know. You can do printf and then %.0s, and that will give you the number of x's equal to whatever input you pass in. So I passed in 1, 2, 3, 4, 5, 6 characters, and you get back 6 x's. And the reason this works is because this is saying after the dot, this is the number of precision we want for any integers, basically. So it thinks this input are integers. So let's say I do printf x %.2s, and then I do add plus subtract. And so you can see I get an x, and then I only get 2 characters from add, 2 characters from plus, and 2 characters from subtract. So lower the precision, and you can see I get 1 character after x, 1 character after x, and then reduce the precision straight to 0, and you just get that. And so we can just do spaces like that. And one way to automate the number of inputs is we can use the sequence utility. So it just prints out a sequence of numbers. And if you just say sequence 10, it prints out 10 numbers. So let's use that. Spaces equals printf space %.0s, and then sequence the indent. And I believe that is that. And then we just need to pass that in here. I believe we can use sed for this. So we pipe that into sed. So let me try this out, test. So the way sed works is that it reads the specified file and you can denote which lines to act upon. So we don't want the first line to be indented, but we want all subsequent lines after the first line to be indented. So what that looks like is the second line to the end of the document, or in this case, whatever line is that's been cut and folded. So then after that, we can say switch. And then we can say, let's see, at the beginning of the line, we want to replace that with the spaces. And then let's see what that gives us. It didn't work. Let's see. What am I missing here? Oh, this is where I messed up. I said space instead of spaces. Okay, let's see if that works now. Okay, that seems to have worked. But if I remember correctly, for hello, yeah, okay. So the problem is that this isn't being printed over here to match interjection. So I just need to pass in max part of speech, max part of speech, and then that should work. Yep, as you can see, we've got our number, we've got our parts of speech that are, I guess, left justified. And then we have our definitions that have their lines broken and indented properly. And with this, I hope you can see for yourself the power just a few simple tools can grant you. Just simple shell script, a simple language like Ruby can build you some tools that are pretty amazing. If you have any questions from me, be sure to check out my website, josephcho.com. If you want, you can also find me at Twitter, GitHub, Reddit. Goodbye.